Section 8.5 is again talking about similar right triangles. Our first example is asking us to find the geometric mean of the numbers. And the way we are going to do that is by setting up a proportion with x. So we'll talk about what geometric mean really is in a minute, but first I'm just going to give you the equation, how to find it. So when we want to find the geometric mean of two numbers, we take 16 over x, some number, set it equal to x over our other number. So this is what your equation is going to look like every time. You set up a proportion with x, you have one number on the top and one number on the bottom of your other fraction. And we solve for x. That x is our geometric mean. So we cross multiply, get x squared equals 16 times 9 is 144. And then we take the square root to figure out what x is, and we get x is equal to 12. That is our geometric mean. For b, we're doing the same thing. So we take our first number over x and set it equal to x over our second number. Cross multiply, x times x is x squared. 2 times 10 is 20. Take the square root of both sides again. We get x is equal. We got to split 20 up. 2 times 10 is 20. See, 2 times 5 gives us 10. And we got 2 times 2 times 5. I can take my pair of 2's and bring one to the outside. So I'm left with 2 square root of 5 is my answer. That's my geometric mean. So what do we use the geometric mean for? When we have a triangle and we draw in our altitude. So remember, our altitude is drawn straight down from the top of our triangle to the base. This is our altitude, some distance x. The length of that altitude, its length, is the geometric mean between the two segments of the hypotenuse. So when we draw this altitude, our hypotenuse is broken up into two segments, and I'm going to call them A and B. This is our hypotenuse because it's straight across from our right angle. Now we can call this line here our altitude, which also equals the geometric mean of A and B. So when we set up our fraction, just like above, if we're finding the geometric mean of A and B, that means we take A over x, set it equal to x over B. So what it's saying here is that when we solve this proportion for x, that x is going to give us this distance right here. Our first example here is asking us to find the indicated measurements on our triangle. So the first thing it's asking for is b, and b is our whole hypotenuse of our large triangle. So that's an easy one. We know that the two segments are 3 and 5. We can find b right away by adding 3 plus 5, which gives us 8. Then we need to find d. So if we know two sides of our large right triangle here, we know this side is d, this side's 8. We can't use the Pythagorean theorem yet to find d on our big triangle because we don't know this side down here. So I'm going to skip D and come back to it, and I'm going to start with H, because H is our altitude or our geometric mean of that triangle. And we just learned we can find that by taking the geometric mean of these two segments, 3 and 5. So if we have 3 over x is equal to x over 5, we can solve for x and figure out, sorry, those shouldn't be x's, those should be h's, because that is our variable for the geometric mean here. So if we take h times h, that's h squared. 3 times 5 is 15. Square root. I can take that 15 and break it up into 5 and 3. So I know I can't really simplify that 15 much, so I'm going to keep it as square root 15. Because even if I put 5 times 3 under there, I have no pairs of numbers that I can pull out, so I might as well leave it as square root 15. Now that I have h, I have a right triangle right here, where I know h is square root of 15. That's one leg. My other leg here is 3. And I'm trying to find D, my hypotenuse. So I just outlined this right triangle in black here. We know this is square root 15. I can find D by using the Pythagorean theorem. So if I have a squared plus b squared equals c squared, I know my a is square root 15 squared, my b is 3, and my c is D, my unknown. 15 square root of 15 squared is 15. 3 squared is 9. And then that gives me D squared. 15 plus 9 is 24. Square root. Let's see, I can break 24 up into 12 and 2. And then 12 can be broken up into 6 times 2. 6 is 3 and 2. So I've got 3 2's and a 3. D is equal to the square root of 2 times 2 times 2 times 3. Take out a pair of 2's. So I forgot to take out the 2. And I'm left with 2 times 3 underneath. So I can write D equals 2 times the square root of 6. Okay, number 2. Number 2, I know that I'm looking for h, but in order to find my altitude, h, I need to know what t is. And if my whole side is 13, and this piece right here is 9, I know there is 4 left for t, because 13 minus 9 gives me 4, and that is going to be my value for t. Now that I know both those pieces, I can find my geometric mean. So if I have 9 over h equals h over 4, 9 times 4 gives me 36, and h times h, h squared. Take the square root, and I get h is 6. Now I'm looking for r and s. The first thing I'm going to look at is I have a right triangle right here. I know my h is 6, this piece is 4, and this is my unknown, my hypotenuse. So this is going to be my C, 4 is going to be my A, and 6 is going to be my B. B right here. So when I use my Pythagorean theorem, A is 4, my B is 6, and my C is S, my unknown. 4 squared is 16, 6 squared is 36. 16 plus 36 gives me 52. Square root on both sides. I know 52 can be divided into, let's see, 2 and 26. 26 gives me 2 times 13 is 26. Can't divide 13 up anymore, so I know that I'm going to get 2 times 2 times 13 equals S. I have a pair of 2's, so I'm going to pull that out front. 2 times the square root of 13 equals S. Okay, then my final piece, R. You can find it in a couple different ways because now that I know all my other sides, I have a bunch of different right triangles. I have my large right triangle. I know that this right here is 2 square root 13. My big side is 13, my hypotenuse. So my little side, this is going to be my A, my B, which I just figured out with 2 over 13. And my C is 13. So when I plug that in, I get A is R squared. My B is 2 square root 13. This whole thing is squared. And that equals 13 squared. R squared equals 4, sorry, not equals, plus 4 times 13, which equals 13 squared, which is 169. 4 times 13 gives me 52. I subtract 52 from both sides. I'm left with R squared equals 117. Square root. R is the square root of 117. At 117, I can break up into 3 and 39. Let's see, 39. I can break that up into 3 and 13. So when I rewrite my 13 is as small as I can go, I can't divide that up anymore. I know R equals the square root of 3 times 13, which that gives me, I got a pair of 3's, I can bring one out. 3 times square root of 13 is my value for R.